So this is one that's it really got a lot of interest in the popular press. This is a DART mission. So I got interviewed by BBC Radio on this, and they asked, what was the significance? And I had to think about it, because it really is probably one of the most significant missions that NASA have ever undertaken. And that's not putting anything paid to the Artemis, or James Webb or the Hubble or anything else we've talked about, or, any of the classic missions of the past, like Apollo or, Gemini or any of these. This one is literally the potential to save life on Earth. And what they're trying to do with the DART mission, in effect, is prove that they can divert an asteroid. Now, the whole thing is that the asteroid that they're trying to divert, which was formerly called Didymoon, Dimorphos, which is part of this Didymos binary system, it's a smaller asteroid orbiting a larger asteroid. What they're effectively going to be trying to do is throw something about the size of a golf cart into something 3/4 of the size of the Eiffel Tower. And that's just in kind of length, as it were. I mean, this thing is quite a substantial asteroid, and see how far they can move it off its orbital kind of path. And they think it could be fractions. It could be absolutely minuscule amounts. Now, you think, well, what's the point in that? How's that going to save the world? If you remember the movies Armageddon and Deep Impact and the whole, you've got to collide with an asteroid and blow it up, or that's all science fiction. The reality is that with any of these, what they call potentially hazardous asteroids, hopefully, if we've got our sums right, and this is a big if, we've mapped now probably over 90% of the ones that could potentially wipe out all life on Earth. That's asteroids. That's not anything else. We'll go on to the anything else in a minute. There are also about 60% of the what they call city killer asteroids, which haven't been seen yet. Now, these are your kind of Chelyabinsk and larger size asteroids. So Chelyabinsk was 17 meters wide, airburst over Chelyabinsk, caused thousands of pounds worth of damage, injured hundreds of people, blew in doors, blew in windows, etc. Had that been 3 times larger, millions of people potentially would have died. Because if you look at what happened in Arizona 50,000 years ago with what's called the Barringer crater or meteor crater, that thing's nearly a mile across and nearly 400 or 500 feet deep. That would have wiped out everything with about 100 to 200 mile radius. Every living life form around at that time, 50,000 years ago. And that was 50 meters wide. So only 3 times the size of Chelyabinsk. Now, 50 meters wide, is nothing compared to what they're trying to do with, this Dimorphos system. And if it's successful, fantastic. If we then find an asteroid that, like Apophis was predicted to kind of potentially be an impactor at some point in the future, if we were to find an asteroid early enough, then yes, we potentially could deflect it sufficiently to knock it off course. That's if we've got missions that have a far enough range. So again, goes back to things like SpaceX and Starship and the load capability and the lift capability that's got to put something into its path at a suitable enough distance to make that divergence possible, to make that kind of collision and knock it off course possible. And that's all great with asteroids. My biggest fear has always been, forget the asteroids, it's the comets. Now, with the cometary systems, you've got the asteroid belt in between Mars and Jupiter. You've got 600,000-700,000 known asteroids. That's fine. We pretty much know where they're coming from. If one of them gets bumped and comes our way, we've got 6 months pretty much to do something about it. So not a lot of time. If you go out to the edge of Earth Kuiper belt, which is where New Horizons is, you're looking at the orbits of Neptune, Pluto, and beyond, there are hundreds of millions of objects out there, asteroids and or comets. If you go out even further to the Oort cloud, theorized by Jan Oort, but now pretty much definitely going to be there because we've seen similar cometary clouds around other star systems. You're looking at anywhere between 800 billion to over 1 trillion comets out at 1 light year away from the Earth. Now, you think, well, that's 1 light year away. 1 light year away, if you get knocked in, it would probably take 1 million years, but these things are appearing all the time. We're going to be talking about one of the comets that is going to be hopefully a big thing to see over Christmas soon, that was only picked up relatively recently. If you look at last year, we had Comet Neowise, which was spectacular and only picked up. Typically, comets, when they're picked up, they're crossing what's called the ice line, so they're near the orbit of Jupiter, and that's when the sun's energy kind of lights up the outer part of the comet where all the dust and the ices are, and they start ablating away, start kind of ionizing particles, and you get dust streams and ion streams streaming away from the comet. As it gets closer and closer to the sun, that cometary tail builds up and it gets more spectacular in the sky. But again, by the time it gets close to the sun, or its nearest point either to the Earth or the sun, these things are traveling at over 100,000 miles an hour. So if you've got something the size of Comet Hale-Bopp, which some of us will remember from the late 90s, absolutely beautiful, spectacular comet, the nucleus of that comet was 35 kilometers wide. If you've got a 35-kilometer wide object traveling at 100,000 miles an hour, you can throw whatever you want at it, because nothing is going to stop it. Absolutely nothing. And if you think, oh, we can land on it, well, by the time if we were to detect a comet coming in towards the Earth, we'd have roughly 12 months, anywhere between 9 and 12 months between detection point and impact point. That's roughly what we'd have. So in 9 to 12 months, we'd have to design, build, launch, and get out to sufficiently far enough something to either destroy it, and we don't have any nuclear capability that could do that, because things like the Minuteman missiles and most of our nuclear defenses can't go out that far, so you'd have to load them into Starship. Then you've got all the United Nations protocols where you've got to get around the use of nukes in space, and I'm sure they'd probably sign those off quite quickly. Or in the case of some of our wonderful neighbours like possibly China and Russia, they wouldn't even care. They just launch. If they knew it was going to impact potentially them, they'd probably just launch anyway. But something 35 kilometers wide, what killed the dinosaurs was a third of that size. What wiped out 76% of all life on this planet 66 million years ago was a third of that size. And the other issue that we've got, and we talk about debris, disaster, etc., in the kind of headline for what we're talking about this year, is the amount of space debris that we're going to have to be launching through soon. And we'll go on to that a bit more in a minute. But this is a big problem. This is why I said this mission is the most important mission NASA have ever conducted, because this is deep impact for real. So you think, well, if it hits the ocean, look at what happened in Deep Impact. 71% of the Earth is covered in water. If one of these things hits the ocean and it's more than 50 to 100 meters wide, you're talking about tsunamis several hundred feet in height that'll make the one that hit Indonesia, a decade or so ago and killed 250,000 people look like a puddle in a pond, or a ripple in a pond. So I don't want to scare everyone, but I do. But we really need to get the governments in the world on this, because if they're not, this is life-changing. We talk about readiness for pandemics. Everyone warned about a pandemic. People like Bill Gates, and everyone talks about, oh, he's putting chips in our arms. It's all rubbish. But we were warned about pandemics and the threat of pandemics, years and years ago. And the governments weren't ready for it. The governments in the world weren't ready for it. And now the scientists, the space scientists, are saying, we've got to keep an eye out for this. Statistically, we may only get hit once every 100,000, million, whatever years. But you try explaining statistics to 800 billion comets, because they don't know what a statistic is. They'll just come in. Terry?
Yep. I agree with you totally about the comets. The only thing is, you can only do something about something that you can actually do something about. In this case, the asteroids. As you say, we have mapped a fair number of them. And little Didymos is going to get blasted by 550 kilograms at 24,000 kilometers per hour. Because it is orbiting the larger one, Dimorphos is going to get hit. Didymos is the parent one. What will happen is that its orbit around its parent asteroid will change ever so slightly, and that is what they'll be measuring. If its orbital period is X minutes, it'll be X minutes minus a few seconds, and that cumulatively then, particularly if you're trying to deflect something that was heading for Earth, even if you deflect it only very, very slightly, if you get it early enough, that will be enough to get it to miss the Earth. But maybe we'll talk some other time about the comet threat, because that's the one that terrifies me, because we won't have enough notice to do anything about it. The other thing is that if this thing's coming in at the speed you describe, we then have to get out to it, and you're then approaching it with an incredible velocity, so you certainly won't be able to land on it.
Yeah,
you'll be zooming past it. It'll be past before you even see it. So we need Bruce Willis definitely to land on it.
This is the thing. You look at how difficult it was for the Rosetta mission in Philae. Philae didn't even land on 67p. It bounced over 67p because the harpoons didn't fire. This is incredibly difficult, and 67p wasn't even lit up. It was barely active when they kind of rendezvoused with it, and that was a 10-year plus mission to get all the intercepts. So, it's the orbital calculations, the trajectory calculations, the landing. It's just, to my mind. Anyway, move on. But this is a whole.
Horses,
This is a whole one.